Hello, welcome. Today's lesson is on concentration, specifically molarity in chemistry. And you're probably familiar with some concentrations. Maybe you've made some nice lemonade, looking forward to lemonade this summer, and you got a mix and it said to mix 1 tablespoon of lemonade mix per 1 cup of water. That would be a concentration. Maybe you've seen in the news things like lead in drinking water, and they give a concentration that lead should not be above 10 micrograms per liter. That's a concentration. Or maybe in a chemistry lab, you've seen a bottle that's listed like this bottle of hydrochloric acid, says 3 molar, which means there are 3 moles per liter, and that's a concentration. So concentration has 2 units, one describing the solute and one describing the solvent. The solute is what is dissolved. So the salt in salt water is an example. The salt would be the solute. The solvent is the material the solute is dissolved in. That would be the water in salt water. And concentration then relates the amount of the solute to the amount of the solvent or to the amount of the total solution. There's many different units for concentration, and we're going to concentrate on molarity, and molarity is moles of solute per liters of solution. There's a lot of other ones: formality, normality, molality, weight percent, volume percent, weight to volume percent, parts per million, parts per billion. Lots and lots of different concentration units that all relate something about the solute to something about the solution or the solvent. So let's take a look at just a couple of these. Parts per billion tells me how many grams of solute there are in a billion, or 10 to the 9th grams of solution. What about weight percent? Weight percent is how many grams of solute you have in 100 grams of solution. We're going to look today mostly at molarity, moles of solute per liters of solution. So what if I have a problem and it asks me to solve for molarity? Well, there are 2 different methods, and you're going to get to choose which one you like to do, but there are 2 different methods to this. Molarity has 2 units. It's moles per liter. So if I'm solving for something with 2 units, and we've done this before, like at the very beginning when we are doing like miles per hour as some conversion examples, what if I have to do moles per liter 2 units? Method 1 says you can solve for the moles, then you can solve for the liters, and then you divide the 2 answers. Method 2 starts with the fraction. What? We usually don't start with a fraction when we're doing unit analysis. But it starts with a fraction because we're going to end with the fraction, because molarity is moles per liter, which is a fraction. So method 2, we start with a fraction, so we end with a fraction. And that fraction has to involve the solute on the top and the solution or the solvent on the bottom. So let's try a problem solving using method 1. Here's the problem. What is the molarity, which is moles per liter, of a sodium hydroxide solution that was made with 78 grams of sodium hydroxide dissolved in water to a volume of 500 milliliters? So we're going to solve for moles, then we're going to solve for liters, and then we're going to divide the 2. So it gives me 2 pieces of information, and I'm going to have 2 problems, one solving for moles, one solving for liters. So which one do you think you start with if I am going to solve for moles first? So pause and see if you can figure out, should I start with 78 grams of sodium hydroxide if I want to solve for moles, or 500 milliliters? Which one will help me for moles? Hope you got it right. I'm going to start with the 78 grams of sodium hydroxide. I'm going to use this to solve for moles, and I'm going to use this to solve for liters. So 78 grams of sodium hydroxide over 1 equals how many moles of sodium hydroxide? So then I have to figure out what conversion factor am I going to use? Well, we've had a lot of problems like this. I got to get rid of grams. Where do I get rid of grams? Pause the video and see if you know where to get rid of grams. Hopefully you said the periodic table. So I look up 1 sodium, 1 oxygen, 1 hydrogen, add them together, and I get 39.997 grams of sodium hydroxide are in 1 mole of sodium hydroxide. So here grams cancel. I am at moles of sodium hydroxide. So now all I have to do is the math. 78 divided by 39.997, it gives me, rounded to 2 sig figs, gives me 2.0 moles of sodium hydroxide. So I solved for moles. Now I have to solve for liters. So I'm going to solve for liters. What do I start with? Pause the video and see if you get this right. Am I starting with the 78 grams of sodium hydroxide, or am I starting with the 500 milliliters? Hope you got that right. I'm going to start with the 500 milliliters. That will help me get liters. So I'm solving for liters. I start with 500 milliliters. And now I need a conversion factor. This you should have probably memorized. You can have it on a 3x5 card, but this is one I would memorize. So hopefully you know that there are 1,000 milliliters for every 1 liter. So I put the milliliters on the bottom so they'll cancel. And then I just have to do the math. 500 divided by 1,000 gives me 0.500 liters. And be careful, there was a decimal here, so that meant these were 3 sig figs. So I still have to have 3 sig figs in my answer. So I'm not done with this problem yet, but I'm getting close to it. I solved for moles and I solved for liters. Now I have to just divide the two. So I ended up with 2 moles of sodium hydroxide and 0.500 liters. So now I divide the two and I put that in my calculator. I get 4 moles per liter. And the abbreviation for moles per liter is a capital M. So when you see capital M, I want you to think moles per liter. So my answer is 4 moles per liter. So what is the molarity of sodium hydroxide solution that was made with 78 grams of sodium hydroxide dissolved in water to a volume of 500 milliliters? 2 moles divided by ½ liter gives me 4 moles per liter. What if I want to use the second method? Maybe you like this method better. You get to choose. The same question, what is the molarity, moles per liter, of a sodium hydroxide solution that was made with 78 grams of sodium hydroxide dissolved in water to a volume of 500 milliliters? So I am going to solve for moles over liters. Instead of just solving for moles and then solving for liters, I'm going to solve for the whole thing at one time. I'm going to solve for moles per liter. Because we end with a fraction, moles per liter, I am actually going to start with a fraction. Wow, we rarely ever do this, but we do in this case. So I'm going to start with a fraction that has the solute, the thing I'm dissolving, in the solvent, or the solution. So 78 grams, I'm going to dissolve the sodium hydroxide, so I'm going to put that on the top of the fraction. I'm going to dissolve it in water to a volume of 500 milliliters, so I'm going to put that on the bottom of the fraction. So here we have it, step 1 of unit analysis. I'm looking for moles per liter, and I'm going to solve it at one problem. I'm starting now with a fraction. I'm going to put the 78 grams over the 500 milliliters. Now what do? Well, I have to change grams to moles, and then I have to change milliliters to liters. So how do I change grams to moles? Well, like we did last time, I looked on the periodic table and I found that there are 39.997 grams of sodium hydroxide per 1 mole. The mole goes on the top, the grams cancel, and I'm left with moles of sodium hydroxide per 500 milliliters. But I don't want milliliters, so I have to keep going. I now have to cancel out the milliliters and get to liters. So how do I cancel out the milliliters? I multiply by 1,000 milliliters over 1 liter, so my milliliters cancel. And now if I look, grams cancel, milliliters cancel, I'm left with moles of sodium hydroxide, and I'm also left with liters, which is good because that's what I want. So now I just get my calculator out, 78 divided by 500 divided by 39.997 times 1,000. What do I get? 4.0 moles per liter. So, same answer, different method. Now you get to choose on the problems we have in class. Do method 1, you solve for moles, solve for liters, and divide the two. Or if you want to do method 2, where you start with a fraction because you're solving for a fraction. You're going to solve for moles per liter in one fell swoop. So there you have it. Concentration. Thanks for listening.